Hey there, this is Mike Watka. I'm here tonight to demonstrate the bowling game kata, which you may have seen before, but this time instead of using traditional test-driven development or TDD, I'm going to show you how to do it using TCR or test commit revert. The test commit revert concept was codified by Kent Beck, who also, for the record, codified TDD. It basically is a twist on it that applies the discipline of source control into the mix. Generally with test-driven development, you write a failing test, you make it pass, and then you refactor if needed, and you proceed in that cycle until you're done. With TCR, instead of writing a failing test, you try and work in such tiny steps that you keep your tests passing at all times. So the way it works is you run your tests, and if they pass, you commit the current state. If they fail, you revert back to the previously passing commit. What this the result of this approach is that you're not very willing to take the risk of big steps, because if it fails, you lose everything you just typed. This method isn't very tenable if you are if you don't have tools to help you. So I've built some minimal tools. Let me show you what they look like. First of all, we have the actual TCR script. So this is what it is at its most basic level. We run the tests, and if they work, we commit. Otherwise, we revert. TCR. Test just runs go funct and go test in verbose mode. Commit is very simple. I'm using the same message for all of my TCR commits, and there's a reason for that. That'll become clear in a moment. If things don't work, we just do a get reset hard. There's also another tool that I integrate with from my editor, which is this squash.sh, which basically says show me all of the commits from where I last push up to where I am now. Find the ones that say TCR, which should be all of them. Show me how many lines there are, and then trim the white space, and we do a get reset soft back to that many commits, which basically rolls up all of the TCR commits into a single chain set, which we can then do a get commit on. So I have both of those integrated into my editor, and today we'll be using Goland and Sublime Merge for most everything we're doing. And I also have a little initialization script that will take all the work we do in this exercise and push it up to GitHub for future reference. So let's just begin. This exercise was kind of made famous by Robert Martin, or Uncle Bob as he's often known. And we're just going to do another demonstration of this. Before we get going too far, I'll show you how the tools work. So I've just created a test file, and this seems like the right time to start running the TCR tool. I've created a hotkey that will run it. This is the output. It ran go test, everything passed, there wasn't anything to run, and it committed the results. And if we bring up a little window here with Sublime Merge, you will see that we now have a single TCR commit, which is just this file that I just added. Okay, so let's add a little bit more. And as I work, I'm going to try and announce every time I run the TCR tool. So TCR, that passed. There's another commit. I'm going to be using a library called GUnit, which I developed at Smarty Streets, and we use to test all of our code there. It's an XUnit style thing, so we have this test setup method, and we can define as many test methods as we want. They can be named whatever we want. We're going to need some sort of game structure, and we can TCR that. Everything's passing, by the way, just to give you a flavor. This is the flavor of the output. This is the test output, and everything is passing, so it's being committed. Just to give you also an example of what it looks like if the tests don't pass, we'll introduce an obvious compilation problem and run TCR, and you'll see that the compile failed, go test failed, and we have now reverted back to the last commit, and that ugly stuff is just gone. One of the distressing things for people is that, oh no, it's going to delete my code, but that actually becomes a blessing. And becomes a real advantage to this method. Okay, we're going to move this into its own file, and we'll split things so you can see what's going on. Okay, we can TCR that as a new commit. We'll need to instantiate this game struct at the beginning of each test so it starts fresh. Just to start off with, I want to make sure that the score starting out is just 0. And this is so simple, I think I can just implement it right here and run TCR. Everything passes. That's great. This is the kind of assertion I'm going to be using a lot in this example, and so I'm going to extract a helper. Each time we're going to want to pass in an expected score, and this is the actual assertion. So assert score, an expected value gets passed in. That should TCR. It does. I'll inline this. That should TCR. Reorder that. That should TCR. And already you can see that we have a rather long stream of tiny little commits at each step of the way. Now you wouldn't want to push this in this fashion with all these little commits that don't really say anything. That's not helping anybody. But what we will get to very shortly is squashing those into a logical change set. Okay, so we know that the score is 0 from the get-go. The first real test that we want to implement is that when you roll 20 zeros, 20 zeros in a row, basically when you throw 20 throws and no pins are knocked down in any of those throws, by the end of the game the score is 0. I haven't really gone into the rules of bowling. I figure you probably already know what that is, and if you don't, you can look up somebody else doing this kata. Uncle Bob does it. It's a really nice demonstration on his cleancoders.com website. You can go check that out. Basically, we're going to roll 20 zeros, which means we need a roll method. It's going to accept a number of pins, and this should TCR. We haven't really changed anything. I'll reorder this function. We'll TCR that. This is a good test, but I think we're going to be doing more of this. So I'm just going to anticipate that and extract a few parameters. This is the number of times to roll. This is the number of pins to knock down. We'll move that out of the loop so that we can extract the loop as a method called roll many. We pass in the number of times and the number of pins. That should TCR just fine. We haven't really changed anything. We will inline these variables and run TCR. We'll reorder this function, run TCR. We will optimize this method signature, run TCR. You'll notice that I am running these tests every chance I get. I'm not letting myself go long at all without running TCR. Okay, everything looks great so far, and our test is quite tidy. We roll 20 zeros. We assert that the score is 0. Very simple. And at this point, we have arrived at our first logical change set. So I'm going to run the other script, the squash.sh script, which is going to roll all of our commits up. It was 17 of them, to be exact. And now we have this change set here, which we can simply expand and see what we already know. This is the first test, which is the gutter game. And there's our first logical commit. Next test. What happens when we roll all ones? Well, we would want to roll 20 ones and assert that the score is 20. That's not going to pass yet, but it will be quite simple to make it pass. We need an integer field called score. We will add to the score with each roll, and we will simply return the score. And that should make everything pass. Everything's great. It just so happens that we're at another logical commit point. So I'm going to run the squash script, which squashes the single commit into this change set ready for me to edit the commit message. Second test, all ones. The next most interesting thing we could work on is the spare. How to calculate the score for a spare. Now, with a spare, that means you've rolled maybe a 4 followed by a 6. That's 10 pins. When you roll 10 pins in a frame, which is usually 2 throws, it's called a spare, and that means the value of the next throw is added twice, once in the spare frame and once in its own frame. So when we have a spare, we count the next throw twice. So we will assert that the score here is 4 plus 6 plus 3 plus 3. Notice that I'm counting the 3 twice. And all of this added up is 16. Now that we're at a problem stage, because this game struct over here on the right is not set up to look ahead into a subsequent frame, and this is just kind of a disaster. If we tried to implement this now, I have low confidence that it would go well. So I'm just going to cheat a little bit. I'm going to skip this test, so it's not going to execute, and I'm going to run TCR, which means all of this code that we just wrote is committed to source control, and we won't lose it in the case of a revert if we mess up. So the reason that we can't implement spare is because we've got design problems. For one, the score function, which should really be calculating the score, isn't doing that. It's just returning a value that's already been pre-calculated. So what we're really wanting to do here is just simply record the roll, and then later we'll calculate the score. So we can TCR at this point with those renames. What we really want to track are the throws over the course of the entire game. Excuse me, the entire game, which, as you hopefully know, the maximum number of throws in a game is 21. It's not 20. There are 10 frames, but in that last frame, if you roll a spare, say in the first 2 throws, you're granted a 3rd throw. Okay, so we need those. We can actually TCR that change. We're not altering anything or hurting anything. Whenever we record a roll, we want to say that throws at this dot throw is equal to pins. And then we need to increment the throw by 1. When you initialize a structure, these values are just 0. If you haven't gathered that already, that's the case. We don't want to calculate the score there. We're going to say for throw in range, this dot throws, this dot score plus equals throw. And everything should pass now. Yeah, nothing has failed yet. That's great. But we're still just iterating throw by throw. And what we really need to be doing is considering the score as a function of frames added up. And we need to be able to look ahead into the next frame. So what if we leverage this throw variable or field, reset it to 0, and now we're going to iterate by frames. We know there are 10 of them, so while frame is less than 10, frame plus plus, now we can deal with the score, which is the throw at this dot throw, which is kind of our marker, our index, plus the next throw, which is this dot throw plus 1. That's our score. And then to advance to the next frame, we need to increment the throw by 2. We no longer need that loop. Everything should still be passing, if I've done this correctly. It is. Okay. Now we're coming to a place where we can almost implement this. I can tell already that accessing into this throws slice is going to get ugly and verbose. So I'm seeing that we've got 2 calls or 2 access operations into this throws slice, one at the throw and one at the throw plus 1. So what if we extract this value, the number 1, as an offset and extract this as a method? Maybe we'll call it pins. It's the number of pins at the offset from the throw that we're currently at. Everything should pass still. It does. We can now inline that offset. That should pass, TCR. And we can replace this index operation with pins at 0. Throw plus 0 is throw. And that passes too. Okay, now we're in a really comfy spot. I'm just going to make note that this right here is the score of the frame, so frame score. That should TCR. It does. I think we're finally in a really good place to implement test spare, which looks like, well, let's see, a spare is the frame score equaling 10. If it equals 10, we have a spare on our hands, and that means that the score is equal to 10, the frame score, plus the very next throw. So the pins at 2 from where we currently are. That's into the next frame. And then we'd want to still increment throw by 2 and make sure to wrap what we had in an else statement. So what we have here is the frame score calculation and the regular frame score calculation. Excuse me, spare frame throw calculation and the regular frame score calculation. Let's TCR that. It should pass now. This is a big moment. We're about to see if we implemented spare correctly. We did. Okay, but it's a little ugly. There's more we can extract here. What about calling this score regular frame? So it's not just doing the score. It's also doing some bookkeeping, advancing us to the next frame. We'll probably take care of that in a different way later, but for now this is fine. Let's extract this as score spare frame. Everything should still be passing. Should have run after that first extraction. We can extract this as a method that means current frame is spare. And that should TCR just fine. Yeah, I think this is a logical commit point. Yeah, let's try that. Squash that. What we have is all of this. Wow, we've really changed the nature of this program, this algorithm now, and we've added our spare. Okay. Third test, a spare. All right. I don't really like this. This, in 6 months' time, if we came back to this code, we might stare at that and wonder, what is the significance of 4 and 6 and 3? So maybe what we need is something called roll a spare. Maybe this together is roll spare with bonus. and somehow that equals 16. Not sure I like that. Let's undo. Back to where we were. TCR should say, oh, there's nothing new. We're still at that commit. Okay. Maybe what we want instead, for some reason it looks better if we just do 5 and 5. That feels more like a spare to me. What if we had some method that was like roll many, but just let us pass in several things? I kind of like that. Roll several. So we're going to roll a 5 and a 5 and a 3. And it's kind of obvious. A spare, 2 5s. I'm okay with that. Let's create this method. It wants to create 3 integers, but that's not really what I'm thinking. I'm thinking we're going to pass in a variadic number of throws, and then we will range over the throws and say this .game .record roll of the throw. Yeah. So that means we can get rid of those 3, and this test should pass. It does. I think I'd like to move it up by all the other helpers. Okay, so 5, 5, and 3 means 10 plus 3 plus 3, that's 16. Okay, the math is present there if you want to do it in your head. Okay, I'd like actually to wrap up these 3 commits back into that original, this logical commit. So we're just going to edit it by hand a little bit. The tooling needs to evolve a little more. It'll get there. Okay, so now we have these 3 tests, 3 commits. That's kind of nice. All right, next, we've already done a lot of the hard work here, and we're ready to see the algorithm kind of come together. Let's roll several again. A 10, that's a strike. Now with a strike, it's the next 2 throws that are counted twice as a bonus. So if we roll a 3 and a 4, that's 7. That 7 will be counted once in this frame, making 17. And then we'll add 7 again in this frame, making 24. So that's 24. That would fail if we ran it right now, but it's not hard at all to implement. If this .pins at 0 is equal to 10. So if the first throw of the frame is equal to 10, we have a strike on our hands, which means that the score needs to increase by 10 plus the next 2 throws. So pins 1 off and pins 2 off. And in this case, this is a subtle point, we don't want to increase throw by 2 because there weren't 2 throws in this frame. There was only 1. So we're going to only increment by 1. And we could do a plus plus, but I kind of like that it's going to be symmetrical. It's going to line up like the other ones. Very important also is that we do an else if and an else to conclude this the body of this for loop. I believe the logic is in place and it should pass now. TCR, there we go. We can do the same kind of extractions here. Score, strike, frame, and current frame is strike. That should TCR. It does. Let's see. I'd like to reorder these though. So we'll put all the scoring methods together, and we'll put the query methods together. These 2 right here. That should TCR like that. Okay, and we've got 3 more commits built up. Is there any more refactoring we want to do? Yeah, I think so. The body of this loop is somewhat formidable to process and could stand on its own in a method, I think. So we'll call it score current frame. That should TCR just fine. It does. We're probably at another nice logical commit point. We'll TCR that white space change. Yeah, let's run our squash and commit this 4th test. A strike. That deserves an exclamation point, I think. The good news is with this kata, the algorithm for the complete scoring method, it sneaks up on you. And the good news, the truth is, it's already here. If we roll 12 tens, we can simply assert that the score is 300. Oh, but not several. We want to roll many. 12. We want to roll 12 tens in a row, not just a 12 and a 10, because you can't roll a 12 in bowling. Yeah, roll 12 tens and assert that the score is 300. And that passes. So what we see on the right is a complete algorithm for scoring a game of bowling. It can score any game. But I think we can do a little better as far as the code, how it's structured. Again, I mentioned that I didn't really like how we're calculating the score and advancing the frame in the same method 3 different times. What I would love to see is it would be great if we could maybe just advance the frame. No, we won't do it there. We could just do it right here. It'd be nice if we could say advance frame from there. Oh, and it would be nice if we could spell it right. Advance the frame. We'll TCR that, even though it's not doing anything. It's not hurting anything either, so it's worth committing. Yeah, advance frame. What would that look like? In both the regular frame and the spare frame, we increment throw by 2, but in the strike frame, we only increment throw by 1. So we can probably just borrow, if current frame is strike, this dot throw plus equals 1, else this dot throw plus equals 2. Yeah, so now that we have that in place, we should be able to get rid of those 3 calls there, and it should pass. It does. Okay, that's a nicer design. I like that a lot. And it might be even better if we weren't modifying score and throw so deep down in the code here. It might look nicer if that was happening all in this main loop. So what I'm envisioning is that we say score plus equals the result of that function, which would require this to return an integer, which means anytime we score, we would need to return that as the result. But those methods aren't set up to do that yet. Let's just see what we can do about that. Yeah. And just return those numbers. I think that should work. It does. Just little tiny steps, and it gives us traction. That's what I like about TCR. Just today we were using TCR, working on a project as a team, and we had to do some what looked like pretty invasive changes to a structure that was depended upon across the project, and we decided, this is too big. We don't know how to do this in small chunks. We better turn off TCR and just go back to the way things usually are and force it through until the compile works and the tests work again. And within a few minutes, it was a mess, and we had to totally revert. And then we decided, let's just try it with TCR. And we found a way to do it step by step. And the traction that it provided was just great. And we were able to finish much faster than we thought we would, and it wasn't that bad. So where were we here? Okay, so, the score is being incremented now here instead of inside the methods, and we want to do the same thing with the throw. This turns out to be much easier. We just need to make sure that advance frame returns an integer, and we just return 1 or 2 as the frame advancement. Yeah. And maybe this is really calculate frame advancement offset. I'm just having fun at this point. Oh yeah, I don't like that. Calculate frame advancement offset. I think advanced frame is fine for now. Okay, so we're just having fun fixing this up. And that's the nice thing about TCR is your tests are running so frequently, you really can do whatever you want with the code. Let's roll all this up into the fifth and final test, the perfect game. And that, my friends, is the bowling game kata. And that's being pushed right now to GitHub. I hope you enjoyed this this little screencast. I hope to do more in the future. Tell me what you think down in the comments. I'd be interested to hear what you think of TCR and how you what your experience is in trying this out. Thanks a bunch. Have a good night.